Hello everyone, you are all welcome to lecture number 1243, and today's topic is the chemistry of thiophene. Thiophene is having very good history, and the history goes like that one professor of organic chemistry, Victor Mayer, he was teaching, and during the experimentation he found that the benzene which he got or obtained out of sodium benzoate is not giving the color reaction of benzene. Means he added concentrated sulfuric acid in benzene and he did not get the blue color. And after that, he found that in coal tar there is some other type of aromatic compound, but he suspected that other type of aromatic compound may be that in benzene there is some sulfur heterocyclic, and when he found that that type of compound is there, then he gave the name, that is thiophene. So what name was given by Victor Mayer? That was thiophene. Thio stands for sulfur, and then phene stands for benzene. So for some time there was big confusion that this thiophene is the aromatic ring where sulfur is the part, but this was wrong because the boiling point of thiophene was little bit higher than benzene. For example, benzene boiling point is around 78 to 79 degrees centigrade, but thiophene is more than 80 degrees centigrade. Of course it is close but not the same. So it gave the clue that this sulfur content aromatic compound is not 6 member, rather it is 5 member. So then the 5 member concept of sulfur came, and it is thiophene. Thiophene is having aromatic character like pyrrole or furane, all these 5 member heterocyclic. Here the same, so-called it is not pure double bond, and the electrons which are here sitting over sulfur, it becomes the part of delocalized system. That's why thiophene is also showing aromatic character. And once it is aromatic in character, it is flat planar, and it is not non-planar. It is having sp2 hybridization, and it undergoes substitution reaction rather than addition, because if there is pure double bond like this, what I am showing is not pure, rather it is delocalized, and you are having this type of structure, that is resonance structure. And because of this delocalization of pi electrons, thiophene is also aromatic in character, and it undergoes substitution reaction rather than addition reaction. And nowadays thiophene is playing very important role in pharmaceutical and drug industries. The reason, and also in some of the pesticide, insecticide industries, because where the benzene is required, and in place of benzene it is substituted by thiophene, and by substitution with this 5-membered aromatic ring, their bioactivity, the potency of the pharmaceutical drugs, pesticides, insecticides, and antibacterial, antifungal, anti-cancer, antifungal, a lot is increased, is good. So that's why there is lot of medicinal, pharmaceutical uses, and in different industries also, and as a substitute of aromatic benzene ring. So here I have just given in the follow-up summary what I have already told you. Number one, just for a student to pause and copy down in the form of note. During lecture in the year 1882, Professor Victor Mayer found that pure benzene, by heating sodium benzoate with soda lime, it did not give blue color when warmed with concentrated sulfuric acid. From here, all the discovery started to get thiophene. A test for benzene obtained from coal tar, because it was supposed to give blue color with concentrated sulfuric acid. Number two, Professor Victor Mayer later on proved that the coal tar benzene contained a new sulfur compound which is called thiophene. And I have already told you that thiophene is still they were having some confusion that whether the sulfur is the part of 6-member ring or 5-member ring, because both were aromatic in character. Thio means stands for sulfur, phene stands for benzene. Thiophene is present to the extent of 0.6% in crude benzene obtained from coal tar. Even in crude oil, sulfur derivative and sulfur itself is present, and that is responsible of bringing down the quality of crude petroleum, because crude petroleum, first question they used to ask, what is the sulfur and sulfur derivative content of particular crude oil from coal tar. So from coal tar, here I have given that once this thiophene is present in any coal tar benzene, it is treated with concentrated sulfuric acid. That concentrated sulfuric acid will be converted into that is sulfonic acid, and that is C4H4SO3H, that is derivative, and then it is heated in presence of steam. And with that, the thiophene in pure form will be separated out. Isolation from coal tar benzene, the same reaction I have given. Thiophene cannot be isolated from benzene by fractional distillation, that I have already told you, because of very close boiling point is 79 and 81, something like that. So they are very close. That's why you cannot separate by fractional distillation, as their boiling points are too close. It may be obtained from coal tar benzene by treating it with concentrated sulfuric acid to form sulfonate, and by heating with steam, pure thiophene is isolated. So here in continuation, how we can obtain or prepare thiophene. Number two, a simple method is to boil benzene thiophene mixture. Once that mixture you have where thiophene is there with benzene, you boil it with mercuric acetate. Thiophene is converted into insoluble mercuric acetate which regenerates thiophene on boiling with concentrated sulfuric acid. Number 3, the most modern method for preparing thiophene is by heating sodium succinate and phosphoric sulfide. So it is your sodium succinate, CS2CONA, CS2CONA, and then P2S3 means it is that is phosphorus sulfide. So when sodium succinate is heated with the phosphorus sulfide, it is converted into thiophene. Number 4, today in America, that is USA, a very I can say most modern way how butane, when it is heated with sulfur, is fully converted into thiophene. So today thiophene is prepared in USA, America, by heating butane with sulfur, and there is a very simple method with C4 hydrocarbon butane, and when it is heated with sulfur, fully it is converted into 5-member heterocyclic, that is thiophene. So reaction is given. This is your butane, 4S sulfur, and then it is heated and it is fully converted into thiophene. So with this I will stop, and some of thiophene's chemical properties, reactions and structure, how it is behaving as a aromatic compound, and some very important pharmaceutical uses will be discussed. With this I will stop once again. Thank you very much for watching the lecture.